Hello, welcome to Lead Programmer. Today we are going to look at the question maximum subarray. So we have been given an integer array nums and we want to find the subarray with the largest sum and we want to return its sum. Firstly, what's a subarray? So subarray is essentially taking a piece of an existing array. So let's say for example we have this array over here and we want to randomly pick two indexes. Let's say we pick this and this. So essentially this can be a subarray. Similarly, we can choose any two indices from a given array, and that can be our subarray. One thing to note is the elements should be contiguous. We cannot just pick one element from here, one element from here, one element from here, and call -2, -1, 1 as a subarray. It's not a subarray, but a subsequence. But for subarrays, the elements should be contiguous. Okay, so with that out of the way, let's look at the question. So the question is, we're going to find a subarray with the largest sum and we want to return the sum. So we want to select a subarray from the given array, and uh, that subarray should have the largest sum and we're going to return its sum. So one brute force way of solving this is to find all the possible subarrays for the given array, and we keep computing the sum for each and we return the sum. So that's a valid solution, but the time complexity is going to be like n cube or n square, which is not ideal. So let's see if we can do better. So one way you might think would be using sliding window, because subarray problems are generally solved using sliding window. So let's say we have a left pointer and a right pointer initially set to the first element, and we have a variable to keep track of the sum. It's like a running sum, and we also have a max sum variable, and this is the variable that we return at the very end. So we first encounter -2, so the sum would be -2 and the max sum would be -2. It's a good idea to initialize the sums to the first element, and anyways, in the given constraints the size of the array is at least 1, so it's safe to initialize them with the first element. Then we can begin processing at the second element over here. So we notice a 1, so we can update the sum. Now logically the maximum sum so far should be 1, but if we blindly add 1 to the current sum we get a -1, but the maximum sum is not -1, it should be 1. Here what we are trying to do is we have a running sum which is negative, and we are letting that negative sum impact the uh, the positive numbers that we have. So we don't want to let a negative prefix have an impact on the subarray. So having a negative number before any number is useless, because this negative number is going to reduce the value of the sum, but we care about the largest sum. We care about the largest subarray. So a subarray which has a starting number or a prefix of a negative is of no use, because the only job it does is to reduce the sum, but we want to maximize the sum, so we have to ignore the negative prefix sums. So if the sum is negative, so here we notice that the sum is negative, we want to ignore that. We want to ignore the -2. So by ignoring we mean, let's bring the left pointer and increment it here. It now points to 1. Now our sum is actually 1. We are not letting the negative past influence what's coming, and the maximum sum becomes 1. Next, we move our right pointer to -3. We notice that the sum now becomes -2. A max sum still remains 1. Okay, all good. So we move on to 4. Now here we first notice what the sum is. We notice a negative sum. negative sum is going to have a negative impact on what's coming. We want to get rid of it. So to do that, we again update our left pointer, bring it to 4, and our sum becomes 4 because that's the number we are at. And the maximum is also updated to 4. Okay, all good. Now our right pointer goes to -1. So the sum becomes 3, maximum sum remains 4. Then our right pointer now goes to 2, sum becomes 5, the maximum sum becomes 5. Now the right pointer goes to 1, the sum becomes 6, the maximum sum becomes 6. Now uh, we go to -5. Notice that the sum is positive, so it's fine. 6 minus 5 is 1, maximum sum remains 6. Then we go to 4. We notice the sum becomes 5, but the maximum sum remains 6. And that's it. So we come to the end and we just return the maximum sum that we have. So the main observation over here was if the sum is negative, then the sum becomes 0, and essentially sum would then be the number we are currently at. So we ignore the negative past and we start fresh. Okay, so let's move on to the next example. In the next example, we see we have only one number, so that's going to be the largest sum. Let's say we had an example where we had only one element with a -100. So in this case, the output would have been -100 because the maximum subarray is -100. The maximum sum is -100. Let's also run through the last example we have over here. So we notice we have 5, 4, -1, 7, 8. This is a pretty routine um, uh, example. So we first begin here. So the sum would be, first would be 5, the max sum would be 5, and then we come to a 4, so it becomes 9, the maximum is 9. We come -1, the sum becomes 8. We come to 7, the sum becomes 15, the maximum sum becomes 15. Then we come to 8, the maximum sum becomes 23, the maximum sum is 23, and this is what we return. Okay, so let's move on to the solution. Essentially, it's a sliding window solution. So we have a left pointer, and we have a sum. We have a maximum sum. Maximum sum is initialized to -infinity. We can also initialize it to the first element in nums. Both work fine. I also have a solution where I initialize the sum to the first element in the array. So we'll shortly look at that. Okay, but here the maximum is -infinity. Left pointer points to 0. The sum, S's sum, is 0. So here we have a right pointer. The right pointer starts from the first element. We first see if the sum is 0. We don't want negative pass to implement what's coming. So if that's the case, we reset the left pointer, and the sum is essentially what number we are currently at. If the sum is positive, then we're all good. We just continue adding to the sum, and we want to update the max sum as appropriate. Once that's done, we just return the max sum. Pretty straightforward. Another solution that I had was, it's basically the same thing. Ignore L, we do not use the left pointer here. So we just have I to keep track of which index we are currently at. We initialize the maximum sum and the running sum. Running sum is nothing but the sum we were talking about over here. So okay, so we have a while loop which runs till we run towards till we exhaust the elements in the array. So if the sum is less than 0, we want to update the sum to be 0, and to that we add on what's the element we are currently processing. That's it. That's the logic essentially. And if the running sum is not less than 0, we are good. We just keep adding on to the running sum. We update the max sum as appropriate, and we also update the index I, since we are in a while loop and we have to manually update it. At the end, we just return the maximum sum. As you can see, the time complexity of this would be the big O of n, because um, we go through the array once. And looking at the space complexity, it'll be constant, because the space complexity does not depend on the size of the input. We just have uh, some variables doing the job. It does not increase, the space requirements don't increase with the increase in the size of the array. So I hope you found this helpful. Thank you.